Hello dear students, I heartily welcome you all in our video lecture series on design of steel and RCC structures. So as we have started series on design of connections, so in today's lecture number 11, we will learn about strength of bolts and voltage joints. This session will cover tensile strength of bolt and tensile strength of plate. And after completion of this session, we will be able to know tensile strength of bolt and its calculation and how to find tensile strength of bolt as per the IS 800 recommendations, and also able to know and understand tensile strength of plates in bolted connections. So before moving towards today's topic, let's have revision on the topics which we have covered in previous lecture. So in previous lecture, we were discussing about strength of bolts and bolted joints, in which we have covered shear strength of bolt and bearing strength of bolt. So can anybody answer how to calculate shear strength of bolt? Yes. Yes, you are right. Shear strength of bolt can be obtained as VD SB equals to nominal shear strength divided by a factor of safety. And this nominal shear strength can be obtained as we have seen that Fu divided by root 3 in bracket NN into ANB plus NS into ASB. And also we have discussed about the terms used in this formula, and gamma MB for this will be 1.25. Now what about this bearing strength? How to find it now? Yes, we can answer it. We have already discussed in previous session. Yes, again you are right. Bearing strength of bolt is obtained as 2.5 times KB into D into T into FU. Okay, where KB is the bearing coefficient which is depends on edge distance, end distance and pitch distance. Okay, as we have already seen. So in today's session, we will start our discussion or continue our discussion on strength of bolted joint, in which we will discuss about tensile strength of bolt. What is mean by this tensile strength, and what is the need of calculating the strength? So as we have already discussed in failure modes of bolt, that is tensile failure of bolt, when bolt is under the tensile load, there may be yielding of the bolt, and after the end of its limit of carrying capacity of tensile load, it will get fracture. So to avoid such type of tensile failure of bolt, we have to know tensile strength of bolt, and IS has stated that this tensile strength or design tensile strength of bolt should be greater than the tensile or factor tensile force applied on the bolt or member. Now how to find the design tensile strength of bolt? So again IS 800 2007 has given value in clause number 10.3.5 that the design tensile strength of bolt will be equals to TDB equals to TNB divided by gamma MB, where this TNB again the nominal tensile strength of bolt, and which can be obtained as TNB equals to 0.9 times FUB into AN, which should be less than FYB into ASB multiplied by gamma MB by gamma M0. Now here in this formula 0.90 factor is taken. Now why this 0.90? Because the at the time of fracture, the member or bolt will get cracked suddenly after the completion, after the reaching its yielding or strength properties. So to avoid such failure, instead of taking 100% strength, we will reduce it by 10% and take 0.9 times or 90% of the tensile strength of bolt at the net section area. Now what is this AN or net cross sectional area of the bolt and how to find it? So again I has suggested that this net area will be obtained. तो कहाँ निकालेंगे नेट एरिया? ये हम निकालेंगे जहाँ पर आपका थ्रेडेड पोर्शन है और एट द रूट ऑफ थ्रेडेड पोर्शन ऑफ द बोल्ट शैंक, और जनरली ये an लेते हैं 0.78 टाइम्स ग्रॉस क्रॉस सेक्शनल एरिया ऑफ bolt shank. What about this FUB? So this is again we have discussed in previous sessions about the strength of bolts or types of bolts, in which we have already discussed that 4.6 grade bolt. Okay, that 4.6 indicate the ultimate and yield distance of the bolt. Okay, now FIB is the yield strength of bolt. ASB again it is the plain shank portion area or area of the bolt at the plain shank. Gamma MB is the factor of safety for bolt and gamma M0 is the factor of safety under the yielding. So likewise we can find the tensile strength of bolt to strengthen our bolt against the tensile loading. Now next strength is tensile strength of plate. So what is the need of calculation of this strength? ये strength हमको क्यों study करना है और क्यों calculate करना है? Because as we already discussed in modes of failure that plate may fail as tearing or splitting of plate, or maybe tensile failure of the plate because of the number of bolt holes and the exceed of the applied tensile force than its actual capacity or strength of the plate. So this strength of plate should be such that it can bear the applied tensile force on the member. So for this IS suggested design tensile strength of bolt should be calculated as TDN equals to 0.9 times Fu into An divided by gamma M1, where this gamma M1 is the factor of safety for plate material. Okay, and An is the net sectional area of the plate under the bolt line. Suppose there is a plate, here you can see there is a plate which is bolted in zigzag manner. So if we have to find the net area at this section where the three bolts are hold. Okay, now the net area of the plate at this section will be this total gross area minus this diameter of holes. It will give net area of the plate. So at this point it will get tear or get fail under the tensile loading. So this strength of plate at this section should be such that it can bear the factor tensile force. Now here Fu is again ultimate tensile strength of plate or material which is to be joined, and An just we have discussed net effective area of the plate or material. This An can be obtained as B minus N into dH plus summation of P square divided by 4GI, where I is the numbers in series and T is the thickness of the plate or thickness of the thinner plate. Now here in diagram you can see this is the horizontal distance between two bolt line is termed as pitch, as we know this, and the vertical distance between two bolt line is gauge distance. So ये gauge distance और pitch distance हम यहाँ पर लेंगे. इस तरह की bolting को बोलेंगे हम zigzag और staggered bolting. तो modes of bolting हम next अपकमिंग लेक्चर्स में इसके बारे में डिस्कस करें. तो इस तरह से हम टेंसाइल स्ट्रेंथ ऑफ प्लेट और टेंसाइल स्ट्रेंथ ऑफ बोल्ट निकाल सकते हैं. होप यू हैव अंडरस्टूड दिस. सो बेस्ड ऑन these two strengths, let's have short quiz or a question which may ask in your competitive examinations. The question is, as per IS 800 2007, tensile strength of bolt is obtained as, and your options are TDN equals to 0.9 into Fu into An divided by gamma M1. So option B is An equals to under square bracket B minus N into dH plus summation of P square by 4GI bracket into T. Option C is TD or TNB equals to 0.90 times FUB into AN, and final option D is TDB equals to 0.90 into FUB into AN divided by gamma MB. Now, can anyone answer this? We have just discussed this in previous slides. What is the tensile strength of bolt? Yes, you are right. The option D is correct one. That is, design tensile strength of bolt will be equals to nominal tensile strength of bolt divided by gamma MB, and nominal tensile strength is nothing but 0.90 FUB into N. Now, based on this today's topic, in examination it may ask you some of the questions. So these are some of the expected questions. You can note it down. State and explain tensile strength of bolt, and state and explain tensile strength of plates or connecting materials. So today we will stop here. Or in next section we will start discussion on bolt values and efficiency of the bolted joint. Thank you.